Welcome to developing imagery apps using the ArcGIS API for JavaScript and Web AppBuilder. I'm Janaka Katua, and this is my colleague Zhechen Meng. And we are both developers on the Raster team working on providing support for imagery on the web within ArcGIS. So yeah, that includes things like JavaScript API, adding things in the map viewer, and also occasionally Web AppBuilder. So that's what we will be talking about. So let's dive into what our goals really are for this. Sorry? Okay. Can you increase the volume? Is this better? No. Okay. Is this better? Yeah? Okay. All right. There we go. Our goals for this session are really to introduce you to all of the different ways that you can go about creating imagery applications on the web. And to that end, we will be starting with what the core concepts are to leverage your raster data through image services and the ArcGIS API for JavaScript. And then we will move on to exploring some of the maybe lower threshold ways to get started with your imagery applications. And then we'll be looking at a couple of considerations about when choosing what might be the right combination for you, because they can all be used together to maybe create something through Web AppBuilder and then customize it further. But there are certain considerations, so we'll be taking a brief look at that as well. So yeah, so we're starting with image services, how image services can be leveraged within the ArcGIS API for JavaScript, and then some of the authoring tools that are provided through your map viewer in ArcGIS Enterprise, and a smaller subset, I guess, that's provided just through ArcGIS Online that you can use to create your layers and then use them throughout your ArcGIS platform. Then we'll be looking at imagery capabilities that are included in the Web AppBuilder, and finally at the configurable app templates for imagery that are provided. So as you can see, we have quite a bit of ground to cover. Some of them, we've tried to include more detail about the core concepts and some of the other things that we've included in the map viewer. But if there are things that are not covered in as much detail as you would like, please stop by the imagery booth. I'll be available there in the afternoon. So if you have any questions, please feel free to follow up. So let's start with image services. Image services are really a web service that that makes your raster data set or raster data available to the rest of the world. And since it is a web service, it's accessible by any device that supports connecting to a web service. It has quite a powerful REST API that can be used for fast dynamic display, but it also has other things like query capabilities or identify like pixel values and those capabilities. One of the really powerful aspects of image services is the dynamic on-the-fly processing that is supported through image services, and it has a well-known list of raster functions, a wide array of raster functions that can be used together to create really complex and meaningful processing on your image service. And one of the cool things about that is if there is a very well-known workflow with your image service that is used all the time in terms of the on-the-fly processing, that processing template then can be published with your image service and then be accessed in an easier manner by anyone using the service. So image services can be based on a single image or a collection of images. So it can be based on a raster data set, which has certain capabilities like being able to do the dynamic processing using the rendering rule and be able to define the format and the pixel type, in addition to be able to get the raster attribute table. But if it is based on a mosaic data set, that gives you some additional capabilities like being able to define how those images should be mosaic together or querying for specific images in your mosaic data set. So all of those capabilities are exposed through your image service essentially. And additionally, there is a special class of mosaic datasets called the multidimensional mosaic datasets, and that's essentially for viewing or working with scientific data. And this is information like if you would, for example, have sea temperature, and that's a variable across multiple dimensions, say time and depth. So that's a special class of mosaic datasets. And if an image service is based on a multidimensional mosaic dataset, then you get additional information or additional resources with your image service to be able to work, have better granularity and better control over working with that kind of data. So that's a little bit about image services. If you're interested in knowing how to author or the management aspect of imagery and how to share it through image services, there is a great session today at 3, I believe. That's by Cody Benkelman, so that might be a good one to check out as well. So next, let's look at how image services can be leveraged using the ArcGIS API for JavaScript. So there are 2 versions of the JavaScript API, but we'll be focusing more on the 4X series, and later talking about some of the capabilities that the 4X version is not yet up to speed about, but mostly all of the functionality has been ported into the 4X version of the API, and that's what we'll be focusing on. How many of you are familiar with the ArcGIS API for JavaScript 4? Okay. So I'll be going briefly over some of the central aspects of the 4X version of the API, and that one of the core things about it is that it supports both 2D and 3D visualization. And the imagery layer supports both the 2D and 3D versions of the scene view and the map view, and the 4X API is designed to integrate more seamlessly into your WebGIS. So any portal items or layers or web maps that you have, it is designed to seamlessly integrate with that and give you that functionality to work closely with your WebGIS. We have a new architecture that we follow in the 4X version of the API, which is the clear separation of the business logic from the view that renders something. And that applies both to something like the map and the scene view, where your map contains the information and the layer data, and the view contains the information on rendering it. And that has a few benefits, like being able to test it separately. And then in the case of working with map and scene view, you can seamlessly change your map view into a scene view and then create a 3D application and switch between 2D and 3D. It also has a brand new widget framework to be able to build better user experiences. One consideration with the 4X version of the API is that it does have only modern browser support. So it supports IE 11 and above. Coming to the imagery layer in 4X, that is really, in the JavaScript API, that is really a wrapper around the image service. So the data source for the imagery layer is the image service, and it allows you to use that image service as a layer within your map or scene. So it supports both 3D and 2D and 3D visualization. And by design, it gives you full access to the pixel values that you are looking at to be able to have an element of interactivity in your web applications. But also you can attach a pixel filter into your imagery layer and be able to control the rendering of your imagery layer that way. As with image services, it has full support for the server-side processing that is available through Raster functions, and we'll take a look at a couple of examples of that. It also has the multidimensional API to be able to work with scientific image services. And it does have support for pop-ups and query capabilities if your image services are based on mosaic datasets. Query capabilities for mosaic datasets and pop-ups is just a generic capability. So using an imagery layer is very simple. The primary thing it needs is basically the URL to your image service. And then additional parameters like the format or compression quality can also be specified within your imagery layer constructor. So in addition to all of the properties mentioned here, you can also specify things like mosaic rule and rendering rule, but we'll be covering those a little bit more in detail, so we'll come to it. Speaking of mosaic rule, so since imagery layers or image services can be based on mosaic datasets that are really a collection of images, we need to be able to tell the server how to handle all of those images basically in our view. So we can narrow down the list of images that we are looking at using the where clause. So since it's a catalog of images, I can use the attributes or the fields to construct a clause that refines the images that I am looking at. And once that is done, through the where clause, I can also specify the images that I'm looking at, how they should be ordered based on certain criteria. So for example, the mosaic method allows us to do that. And for example, if you have something like a center mosaic method, that will give precedence to the images in the center, whereas something like attribute needs the sort field and sort value, and it will use those to order the images that I'm looking at. The server-side processing on the imagery layer is available through the rendering rule property, and I can create a raster function object and attach that to my imagery layer. So whenever it draws, it will process that image on the fly and show me the processed image essentially. We have a huge list of server raster functions that are supported, and if you haven't seen this resource before, it's really essential to be able to work with your imagery. There are lots of raster functions that are supported just by the server. And these can all be chained together and used together to create a processing chain to be able to work with your imagery. At the upcoming release version of the API at 4.11, that's later this month, we also have support for three renderers in the imagery layer. And the stretch renderer is a new renderer that we are adding specifically for imagery layers. So stretch renderer is for images where we have a very tightly grouped pixel values, and those need to be stretched across a spectrum to be able to better visualize that data. So a use case for that will be when we have a very dark image and we want to be able to stretch those values out to be able to better make out features in that layer. Another use case for a stretch renderer is that when you have a single band image, say for example temperature data, and you want to be able to render it using a color ramp to give it color values that would better signify what the data contains or what you're trying to show the user. So that's another use case for a stretch renderer. A class breaks renderer will bin the pixel values into different classes, and then you can assign colors and labels to those groups of pixel values. Similarly, the unique value renderer will allow you to basically assign symbols and colors to unique values within your image. And both class breaks renderer and unique values renderers actually support the pixel values, of course, but for thematic data where you have a raster attribute table attached to your image service, it also supports working with any of the fields in your raster attribute table. So for something like a land cover service, you would have a class name denoting what it denotes. So that can then be used in your unique values or class breaks renderer. So let's take a look at some of the examples of the properties that we just discussed. So here I have an imagery layer just added to my map with the default rendering that is available through through that particular image service. And what I'm looking at here is Landsat 8 data, which is multispectral, and it's also time enabled. So it's a mosaic of basically the default view that is given to me by the service. So the service has a default mosaic method attached to it, which shows the latest images. But I can also customize it to look at specifically the dates that I want. So I'll go ahead and look at a specific date. And to do that, I can use the mosaic rule property. I can give it a method to signify that I want to give precedence to the images in the center of my view. And here I can filter the images that I'm looking at. So I want to be looking at images that are acquired between 21st October 2018 and 22nd October 2018. And I can create that where clause to filter those images. So once I have that, I can see that I'm looking at only a specific image in the Portland region, and I've narrowed down the images that I am looking at. But now I have this image, I can do some processing on it. So I can calculate the NDVI and look at the vegetation index in this particular area. So to do that, I can use a server-side raster function. So one of the cool things about this particular service is that NDVI is a commonly used raster function for this kind of data, and the service actually has the RFT already published with it. So I can just use the name from I'm looking at the service info, and it already has the raster function infos that come with the service. So here I want to be able to use the NDVI raw data and add that to my imagery layer. So to my layer, I just add a rendering rule, and the cool thing about the 4X API is that if it knows the type that a certain value is supposed to be, it will autocast that value. So I'm not creating a raster function object, even though this is internally a raster function object within my API, but the 4X API will just autocast that into an object. So I've assigned it the rendering rule. And now I can look at the NDVI values, which vary from -1 to 0.78. But say I'm serving this data out as part of my application, and I want to be able to assign some different colors, meaningful colors and labels according to what I'm actually looking at. So to use that, I can use the class breaks renderer and give it based on the field value, which is really the pixel value, give it min-max values for each of the classes that I want to show, and give it colors that would be appropriate for a certain class, and assign that renderer into the layer. And once I have that, I can see that I see all of the healthy vegetation, the dense vegetation in the darker green colors, and the lighter vegetation in the lighter green colors, and I also have a symbology for water. So that's one way that mosaic rule, rendering rules, and renderers come into play when working with your imagery layers. Another example of this would be, here I have some DEM data, but I'm using the DEM data to compute the terrain ruggedness. And the area that we're looking at here is just around Palm Springs, but we can see some really nearly level areas, and then we can see the mountains where we have some extremely rugged terrain. And this is just accomplished also just using a server-side raster function. Let's take a look at that. Okay, so here I have my layer, which is just an elevation, some elevation data. Then we have a raster function, which is actually just using a raster calculator function. And the raster calculator function is very cool. You can create an expression, and the expression will be applied to your image on the fly. So it is very useful for any kind of suitability analysis. So as you can see here, I'm doing some analysis of how much the terrain varies in a small area, and that's how the terrain ruggedness is calculated. I'm giving it the input names, which is the DEM, and the rasters for that is just the $$ signifies the current imagery layer or the current image service. So all of this processing is done on the layer that we are looking at right now, that we're working with. And based on that, once I have the rendering rule, the values from that rendering rule go into the renderer. So I can have the min and I can specify the min and max values for coming out of the terrain ruggedness index, and then assign different symbols and labels to them. So I can see here that I have from level to extremely rugged using the server-side raster function and a renderer. So now that we've looked at some of the capabilities of raster functions, mosaic rule, and the renderer objects, let's look at what we can do just client-side. So for doing client-side processing, we have two things that we need to consider. One is the pixel block, and that is really all of the pixel data that we're looking at any given moment is encapsulated in a pixel block and provided to you. And to do client-side processing or control the rendering, you can use a pixel filter, which is nothing but a function that takes the pixel block and updates it so that the updated version of the pixel block is actually used for rendering. So using the pixel filter and pixel block API, you can create some highly interactive user experiences because it's not constantly going back to the server to fetch more data. Once you have your data, you can just redraw it based on your pixel filter if any of the parameters are changing. So one of the considerations with using the pixel filter API is that it's not integrated with the WebGIS. So if you have an application where you're using a pixel filter, there's no way to save that with your layer within the ArcGIS platform. The schema doesn't support that yet, but you could have a custom saving for that. But it is really in your application. So whereas the other things that we looked at, the rendering rule, mosaic rule, renderer, all of those are saved with your web map. So with the pixel block, you have the height, the width, and the height of the image, of course, and then access to all of the pixels. So this is a two-dimensional array, and each of the arrays further in that array is representing data for one band. So for example, I have a one-band image. This pixels will be an array of an array containing one array, which contains all of the pixel values for that particular band. It also gives you the pixel type. And the mask is an interesting one because it's an array containing zeros and ones, and it's essentially the same size as your array, the band pixel values. And it will tell the layer whether or not to render a certain pixel value. So you can mask pixels based on certain constraints, and only the values that have one corresponding in the mask array will be rendered. It also gives you statistics that contain the min and max and no data values within it. Let's take a look at an example. Okay, so here I have some sea temperature data, and I have a slider here that I can use to mask certain pixel values or restrict the temperature values that I'm looking at. So right now I'm looking at values only from 22 degrees Celsius to 37, and I can move this around to do this just on the client side using a pixel filter, and that's really quick because it just redraws the layer without actually going back to the server to get the updated information. So let's just take a look at how this is done. So every time the slider updates, the redraw layer function is called, and it gets the slider value and it sets the current min and visible? Sorry, the code. Okay, the current min and the current max values just from the slider. And what's interesting is these values, these variables don't belong to the redraw layer function, but these values belong to a function outside that both the pixel filter function and the redraw layer function can see. So they're both creating closures over the current min and the current max variables. So those are updated with the latest values from the slider, and it's just calling a raster layer redraw. So when the layer redraws, it will automatically call the pixel filter function, which has already been set on the layer. And when the pixel filter executes again, it will read the pixels, the mask, and then based on here, it's processing all the pixels. And based on the current min and current max values, it will change the mask. So if a certain value falls within the current min and current max range, it will show that value using 1, otherwise it will hide that value. And essentially that's how the masking is achieved in this case. But this is an example of how you can control rendering using a pixel filter. Using the pixel block that is available to you, you can also just use those values to show something to the user. In this case, for example, we are looking at the land cover composition in a 5-mile radius within United States. So since I have access to all of the pixel values, I can show this dynamically to the user without actually going back to the server for that data. So that brings us to the end of client-side pixel filtering. I would like to talk briefly about the multidimensional data capabilities within the layer. We have a multidimensional definition API that is supported in the layer, through which you can define what dimensions and what variable names you're looking at. So for example, I have sea temperature data, which can be viewed across a time dimension or a depth dimension. So I can create one or more dimensional definitions with the variable name and the dimension values and look at only that dimension data. If a layer is multidimensional, does have multidimensional information, it will have a multidimensional info, which will tell you exactly what dimensions, the variables and the dimension values it contains. So all of that information can be read from the layer and then used through the multidimensional definition API and setting that in the mosaic rule. So that brings us to the end of the capabilities through the JavaScript API 4. I would like to briefly just cover the things that are not supported through the 4x API, but only supported still through the 3x API, and we're still working on bringing a couple of things up to speed in the new version of the API. So in the 4x API, we have 4 layer types, the image service layer, raster layer. Both of those capabilities are essentially covered by the imagery layer in 4x, but the 2 types that are not available are the image service vector layer and the WCS layer. So I would just talk briefly about those. Sorry. So the image service vector layer renders imagery data as vector. So anything that has a magnitude and direction component is rendered as vectors with arrows or different kinds of symbology that make it more meaningful. And the WCS layer supports the WCS OGC WCS convention. Talk briefly about the vector layer. So whenever we have 2-band data denoting either the UV components of vector data or the magnitude direction components of vector data, they are rendered using vector layer. And it shows imagery in a more intuitive way with vector graphics. and it supports different kinds of renderer styles. It could be arrows, or it could be something more well-known like Beaufort wind, or something like the wind barb symbology, where it denotes the wind speed based on the number of notches it has, essentially. There is a default pixel filter, so if you have UV data that needs to be converted to magnitude and direction, there is a default pixel filter that will handle that for you if you use the image service vector layer. And the 3x API also has support for the WCS layer, and it is based on the raster layer in 3x, which allows for full client-side pixel filtering within the using the WCS layer. So that brings us to the end of the capabilities using the ArcGIS API for JavaScript. And these are the documentation resources. I would like to hand over to my colleague, Sachin, for looking at the map viewer and Web AppBuilder.
Cool. So besides the ArcGIS API for JavaScript that Janika just talked about, there are also other options you can choose from to build your own imagery apps. The topics I'm going to talk about today are the following three: the map viewer in ArcGIS enterprise environment, the Web AppBuilder, and the configurable app templates. First, for the map viewer in ArcGIS enterprise environment, it has a variety of powerful capabilities to help you better visualize and analyze your imagery data. I will take the following three capabilities of map viewer as examples. The image filter option allows you to select imagery based on an attribute in a specific geographic area of interest. The filter is based on a metadata attribute associated with the imagery, such as acquisition date, cloud cover, viewing angle, and so on. Once the filter is set up, the results are populated as a series of cards, as you can see on the right side. After making selections, you can create a new layer with the results and add it to your content. The symbology option allows you to enhance your imagery and improve its appearance by applying different renders like stretch, classify, and unique values. It leverages the rendering capabilities in ArcGIS API for JavaScript, and you can access it from the image display pane, which I will show you in a little bit. For the image processing capability, there are two different approaches. One is the dynamic processing, which uses the rendering rule property of the layer. The image can be processed on the fly as the server is processing it in its viewing resolution. Another approach is using raster analysis to produce a persisted output, which is in the source resolution of the imagery, so it's lossless. Then I want to talk about the raster analysis in detail. With raster analysis, you can quickly extract information using spatial analysis and raster models by leveraging distributed processing and storage on ArcGIS server. In order to do that, we have our special raster format called Cloud Raster format, which is optimized for reading and writing large files in a distributed processing and storage environment. In a CRF file, large rasters are broken down into smaller bundles of tiles, which allows multiple processes to write simultaneously to a single raster. This helps boost the speed a lot. The raster analysis can not only be accessed by user interface clients like ArcGIS Pro and MapViewer, but it can also be accessible through the ArcGIS REST API. And once the analysis job is completed, the results will be immediately available in your WebGIS and can be used across the platform. Currently, we have 17 out-of-the-box tools available for raster analysis on MapViewer in ArcGIS Enterprise, and you have the ability to share and apply raster function templates through raster analysis and produce persisted output layers. What's really exciting is that now you can build and edit custom templates on MapViewer by using our newly developed raster function editor. With the raster function editor, you will be able to view, edit, and build raster function templates in Portal you can save a new or updated template to your content or share it with others. After creating or editing a function template, you can apply it right away and run it as an analysis operation to produce a persisted output, which I will show you a demo next. The Raster function editor will be available in this 10.7 release. And I would like to show a demo about the Raster function editor.
It still shows your PowerPoint presentation.
I think I need to. So the scenario is that after the wildfires happened in the summer of 2015 at Glacier National Park in Montana, we want to measure the burn scars using the Landsat 8 imagery from before and after the fire. So we can see that we have the imageries ready. And I would like to show two different workflows you can use the Raster function editor. First, I would like to show how you can create a new Raster function template by using the editor. So with the analysis panel, you click on the Raster analysis, and you will notice a new button pops up, and you can click it to enter the function editor app to create a new Raster function template. So in this case, we can see all the different function items supported in the system. And in this case, I would like to use the arithmetic to process the data. So I can click on the card and it will pop up a description of the function item, and I can click add function to the board. So you can enjoy the same experience on ArcGIS Pro. By double click on the function item, it will pop up a property dialog that you can choose the different parameters. So we want to use the pre-fire ImageryLayer as the first raster input and the post-fire as the second raster input. And we want to use the operation as minus. And click OK. And we will notice that there are two different raster variable nodes shown on the board. And just for demoing purposes, I will just save this current version. And we give it a meaningful name. And we can select which we would like to share with. And we can save it to the content. And save success. So for the second workflow, I would like to show how you can view and edit and apply the Raster function template we just created. So we use the second icon here as the Browse Raster function templates. And we can see the burn scar demo that I created earlier. And I can click select to apply the Raster function template, or I can click the edit to view it and edit it on the function editor. So it brings up the completed function chain. And we have two pre-fire and post-fire raster inputs. We use the band arithmetic function to calculate the normalize the burn ratio with this equation. And we in the variables page, we set the raster as public. So only those two raster input will be exposed to the user. So the user can only change those two values when we trying to apply the raster function template. And after the band arithmetic, we use a minus operation to calculate the change between those two, normalize the burn ratio of one taken from 2014 and then the other one taken from 2015. And we remap the results. So we click OK, and it brings us to the raster analysis panel here. So we can see that as we set the two different rasters as is public, we can only change the two different raster values here. So for the pre-fire raster input, we select the pre-fire, and for the post-fire, we select the post-fire. And we can run analysis to perform the analysis. Oh, it seems that I have a same name file. Okay. So the process will take about 1 minute or two. So because I already have the results, I will just show the result here. So this is the result that produced by the Raster function template we just saw. And in order to make it more meaningful, we would like to change the image display. As I mentioned earlier, we can select the symbology type as classify. And we only care about the two top values. So we set the lower two to no data. And when we hit apply, it will render the top layer that we just produced. So we can easily see the burn scar on the top of the layer.
F5. F5.
Sorry, bring. Okay. Okay, coming back to the slides. My next topic is the image service capabilities on Web AppBuilder for ArcGIS. With the Web AppBuilder, you can quickly build 2D and 3D web apps without writing a single line of code. With the developer edition, you can create custom widgets and themes and boost your productivity by expanding the framework. The apps you build with the Web AppBuilder can run on any device. Web AppBuilder includes many out-of-the-box widgets such as layer list, legend, query, attribute table, pop-ups, and so on. These widgets provide fundamental functions to easily create web apps. And there are two out-of-the-box widgets specifically designed to work with image services. The image measurement allows you to perform measurements on image services with a mensuration capability, and the object viewers can display image in a native coordinate system using an image coordinate system. Next, I would like to show a demo of how to quickly create a web map using the Web AppBuilder with those two widgets. So on this web map, we have the also layer and the object viewer that taken at Washington University at St. Louis. So we can create a web app by using the Web AppBuilder. We can access it from the share button here. And we click create a web map. In this tab, we can give a name to the app we are building. And at the bottom, we can get started to be directed to the Web AppBuilder page. So when entering the Web AppBuilder, we can change the different themes, different styles, different layout of the widgets. And on the second, we can change the maps because we jump from the web maps we are going to use. So we don't need to change that. And on the widgets pane, we can select the widgets that we want to use. So in this case, I want to use the object viewer. And we add it by click OK. We select the object viewer for the layer input, and we keep everything as default. When we click OK, we can notice that the widget has been added to the web app we are going to build. So by using it, we can click on it and see how it works. So you can zoom and pan around on the aerial object view image. And you can also change the angle to see the imagery from different camera perspective. And the object viewer widget also comes with the image measurement widget. So with this widget, you can measure the height and some area information. For example, if I want to use this.
That would be maybe like a tall building. So I can...
Yeah, let me find a better building that we can use. So if we want to measure the height of this building, we can click on the widget. We select the height base to top, and we draw a line from the base to top. And the result will show in a pop-up. So it's like around 10 meters. And after you complete it with the editing, you can launch your web application. And after launch, it will be hosted as part of your WebJS platform. So it can be used or shared to others immediately. And coming back to slides.
Slideshow. Start from cursor. Yeah.
So with the Web AppBuilder Developer Edition, you can have the access to Web AppBuilder image services widget, which we call a WABIS. It is the set of custom widgets to be used in Web AppBuilder that are designed to work with image services. For example, the image selector widget allows you to search an imagery layer by a field, as well as set primary and secondary layers. The change detection widget allows you to calculate the difference between the primary and secondary layer rasters. The render widget sets the service functions and the stretch on the primary layer, and the export widget allows you to either save the top imagery layer to a content importer or to export the same image locally as a TIFF file. So in the following demo, I will show some of the Web AppBuilder image service widgets on the Landsat Explorer. So on the Landsat Explorer, we can see some demos of the widgets we just talked about. So by using the time selector, we can move the time slider to select the time we want to set for the primary and the secondary. Currently, I set the primary as the May 4th of 2018 and the secondary as August 16th of 2015. And we can use the swipe tool. So with the swipe tool, we can drag left and right to see the difference between the two days that the imagery were taken. And with the change detection, we can compute the change between 2 days. We can select the different index we want to analyze. For example, here I want to analyze the difference in vegetation index, and I would like to use the difference mask as the mode, and we can set the threshold values for the change in negative and positive. So once we are finished, we can either save the top layer to our ArcGIS Online, or we can export the top layer as a TIFF file to a local. And in order to access that, you can we have a GitHub repository that you can download and use all of those different image services widget for the Web AppBuilder Developer Edition. And coming back to slides. Besides all these options mentioned above, you also have the option to use the configurable app templates to create a web app, which is the fastest and easiest way to go from a map to a shareable app. There are 3 different configurable apps to interpret imagery data. First one is image mask. It is for identifying areas of an image that have changed over time or that met user-set thresholds for calculated spectral indexes. The image visit is for reviewing the attribute of a predetermined sequence of locations in imagery. And the imagery viewer is for visualizing and exporting images through time and space.
Do you want to go back?
Sure. So those are the 3 configurable app templates that you can use for to incorporate the imagery data.
So they are available in ArcGIS Online already, and they are coming to the next version of Enterprise.
So at the end, you may wonder, what should I use to create my imagery app? Here are some comparisons among these options. With the ArcGIS API for JavaScript, you can enjoy the latest features, the most flexibility. You can create, customize, and optimize full-featured 2D and 3D web apps. But on the other hand, your app needs to be hosted on your own server or third-party resources like Amazon AWS. With the Web AppBuilder, there's no coding required, and you can use all those ready-to-use widgets and configurable themes. You can choose to host your apps online or run them on your own server. You can also use the Web AppBuilder to create custom app templates. With the configurable app templates, there's also no coding required, and it is the fastest and the easiest way to go from a map to a shareable app. And there are many options of the configurable app templates that you can choose from. You can easily share your app with others. You can choose to host your web app on ArcGIS Online. It can reside on your organization server, or you can use the third-party resources as well.
So one of the things I would like to mention is that with a Web AppBuilder, there is a developer edition that is very customizable, but any apps from that are, of course, need to be hosted on your own server. The thing with configurable app templates are also that they have a certain level of configuration as part of its options, but you can also pull down the code and configure it more using some of the JavaScript API capabilities, because they are essentially based on the JavaScript API.
Cool. And then I will hand back to Chanika to talk about the road ahead and the conclusion.
Yeah, some of the features that we are looking at right now to bring to the coming versions of the API are support for visualizing vector data. As I mentioned, the vector layer currently exists in the 3x version, but we'll be bringing similar visualizing capabilities to the layer in 4x. Then we are working on performance enhancements to make the decoding of the imagery data in your layer non-blocking, so it wouldn't execute on the main thread and be worker-based. So that takes the load off the main thread. So whenever you're wanting to include interactivity in your applications, that would be faster because of that. And then we are also working on time support. When it comes to map viewer, we introduced the function editor in the 10.7 release, but it's not yet available to do dynamic on-the-fly processing. It is only available for raster analysis to create persistent outputs. But we think it's going to be very powerful if you can do that, use those function chains created just for dynamic processing. So we are working on building that into the map viewer to be able to just apply it on the layer on the fly. Yeah, just to review what we looked at some of image service capabilities, how they are leveraged within the JavaScript API. Then some of the imagery capabilities in map viewer, such as raster analysis, enhancing the symbology, and also being able to author whatever layers you create from there, and then being able to share it through to the rest of your WebGIS. And then we looked at some of the imagery capabilities in Web AppBuilder, both the inbuilt out-of-the-box widgets and the Web AppBuilder image service widgets, which are available for your developer edition. And then finally, we looked at what are the configurable app templates. The configurable app templates, if you are curious about those, we can stop by the booth and then we can talk more about that. So thank you for joining us. Please give us your feedback. We would love to improve in the next session that we do. So would highly appreciate that. Thank you. It's hosted by Esri. Yeah.
Can you create your own service on ArcGIS Online?
Not at the moment. That functionality is already there in Enterprise to be able to create an image service from your data, but it doesn't exist in Online yet. But that's something that yes, it is planned for. So if you have your data store, basically that contains all of your imagery, we are working on bringing that capability to be able to say, okay, if I have a data store which contains all of my imagery, ArcGIS Online, just take all of that imagery, don't copy it over, just reference that and create an image service out of it.
You still have to have Enterprise to do that.
Right, at the moment, yes.
But
yeah.
when you get that capability in ArcGIS Online, does that Enterprise requirement go away? That's a pretty big requirement.
Yeah, I understand. And that's what the plans are, but I'll need to verify what the exact plans are and when that functionality is coming. But I think that's what the eventual goal is, to be able to say, just host this for me. Or the data itself is not hosted, but the image service is hosted. So.
And is there any way, I'd really like to get a copy of your NDVI Landsat code?
Sure.
Would that be possible?
Sure, yeah. Okay. Yeah. I can share that. I can share the part without the renderers because the renderer is actually referencing an internal, like the dev version of the API, which we can't share. But the renderer is coming to 4.11, which is just the next version. So that's end of March somewhere. So once that's out, you are able to use it with the renderers. But I can share everything before that, like with the rendering rule. I can share that with you for sure.
One.
Sure.
You said with the Mosaic data sets that you could support pop-ups. I'm just wondering if you could sort of get the image date.
Yes. Yeah. So you can do that through ArcGIS Online or the map viewer in Enterprise and ArcGIS Online. You have tools to configure pop-ups, and there you can define what dates exactly, what fields exactly you want to show in your pop-up. And there's a huge amount of customizability that's available to you, where you can define just how you want it to look, the markup that accesses to the different field values, but you can also do it through the API.
So, Mosaic data set, that's all these things?
Mm-hmm. Yes.
Okay, and you could potentially mouse over to show
Yeah, so there is the underlying API, the REST API that it uses is identify, and that's leveraged by all pop-ups. So in ArcGIS Online, you have UI tools to be able to do that, and once you define it, right, any application that you build, that you pull in that layer into, that pop-up definition is going to be stored with your layer, and then once you pull it into any other application, it should also honor it because it's part of the web map schema. But the UI tools in the map viewer, it can also be done through the API. Yeah, I will have to find out exactly how that can be leveraged using the API, but there are quite extensive. Yeah, but quite extensive support in terms of the UI ways to do that. Yes.
I'm assuming you're going to add WCS support to 4X at some point?
Yes. Yeah. But I'm not aware of what release that's being planned for at the moment, but it is in the talks, sort of. Yeah. we're kind of deciding what's the best approach is to support the different data sources that you can have other than image services as well, and what would be the best API design to be able to support that. So it's something that is being designed and discussed, but it's not. We don't have like a proper date for when it will be released.